Section 1, we talked about tangent lines. Now, a line that is tangent to a circle forms a right angle with the radius. So, this piece here, my radius goes from the center of my circle to the outside of my circle. So, this is what I'm calling the outside. So, from the center to the outside of my circle, that value there is what we call the radius. So, my tangent line should be here. The tangent line is always formed with the radius of the circle. So if the line is tangent, then I should have a right angle that is formed with the radius. So now that I know that this is a right angle, I can now solve for x by using the triangle sum theorem, which says that all of the angles of the triangle have to add up to be 180 degrees. So I'm going to take 180. I'm going to subtract 90 for my right angle here. Then I'm going to subtract 28 from that, and that's going to allow me to solve for x. So 90 minus 28 leaves me with 62. So x has a measurement of 62 degrees. Now for problem 2, same type problem. This piece here is my radius. So my tangent line should be here. Tangent and the radius is going to make a right angle. So now I can take 180, subtract 90 first, leaves me with 90. Then I can subtract 59. So 90 minus 59 leaves me with 31 degrees. Same thing for problem 3. My radius is here. My tangent line is here, so my right angle is formed, and I have 180 minus 90, and then minus the 33 degrees that was given, so 90 minus 33 leaves me with 57 degrees. Now, also in section 1, we talked about the perimeter, finding the perimeter of a triangle given the information. So, one of our theorems says that if I have two tangent lines that meet outside of the circle, that they are congruent. So, these two tangent lines here, they meet outside the circle here. So that means that these two pieces have the same measurement. These two lines here meet outside the circle. They are both tangent. So therefore, those two pieces are congruent. And then the same thing for my last portion here. These two are tangent and meet outside the circle, so those two segments are congruent. So in order to find perimeter, I need to add up all of my values that I have for the pieces of my triangle and add them together. So 6 plus 6 plus 3 plus 3 plus 8 plus 8 gives me a value of 34. So 34 centimeters is my perimeter for problem number 7. Now, in section 5.1, we also talked about how to find the value of the radius of the circle. So notice these pictures are a little different than the pictures that we had on the front. So this is a radius value here. This piece here is also a radius, but this piece that extends past my circle has a value of 1. My tangent line has a value of 3. So in order to find the length of R, I can use the Pythagorean theorem, since there is a right angle here. Now remember, the Pythagorean theorem can only be used with right triangles. My Pythagorean theorem is a squared plus b squared is equal to c squared. And C, remember, is always your hypotenuse. My hypotenuse is always across from the right angle. So here is my right angle. So that means that this side here is my C value. So that gives me R squared plus 3 squared is equal to R plus 1 squared. Notice that I put the R plus 1 in parentheses and the squared portion is on the outside. So now I need to simplify to solve for R. So when I factor this out, that's going to give me r squared plus 2r plus 1. So if you need to, over to the side, come over and do your scratch work. R plus 1 squared means that I have to write it twice and multiply it together. So r times r is r squared. 1 times r is 1r. R times 1 is 1r. And then 1 times 1 is a plus 1. So now I need to combine my like terms, which gives me r squared plus 2r plus 1. So now to finish solving for r, I'm going to subtract r squared from both sides. When I do that, r squared cancels out. I'm left with 9 is equal to 2r plus 1. Subtract 1 from both sides. 8 is equal to 2r. Then divide both sides by 2. R is equal to 4. So for problems 5 and 6, I'm doing the same thing. So for problem 6, this is my radius, this is my tangent line, so there is my right angle. So this piece here, across from my right angle is my C value. So r squared plus 14 squared is equal to r plus 8 squared. That gives me r squared plus 14 squared, which is 196. Is equal to r squared plus 16r plus 64. So now I'm going to subtract r from both sides, r squared from both sides. It's going to cancel out. 196 is equal to 16r plus 64. I'm going to subtract 64 from both sides. That gives me 132 is equal to 16r, and then divide by 16. So r has a value of 8.25. So those are the 3 different type problems that we talked about in section 1. If you need more information about your theorems, please refer back to your note sheet.